Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. My name is Ratu Ramadhania, and today I'm going to present the summary of the journal. But the title is a comparative evaluation of seepage and stability of embankment dams using GeoStudio and Plaxis models, the case of Gomit dam in Amhara region, Ethiopia. So in this presentation, I will highlight the key findings, methodology, and conclusion from the study, and I hope it provides valuable insight for our discussion. So this is the journal that I reviewed. Title is a comparative evaluation of seepage and stability of embankment dams using GeoStudio and Plaxis models. The case of Gomit in Amhara region, Ethiopia. The journal is from Water Conservation Science and Engineering, with the volume 7, number 4. The page is 429 until 441, but the year is 2022. So first, for the introduction, there is 2 points that I will talk about. The first one is about the dam safety challenge, and the second one is this research gap. So the dam safety challenge, environment dams face critical challenge that related to seepage slope instability and deformation. These earth-filled structures that typically built on soft materials susceptible to scoring and water infiltration that require continuous monitoring and evaluation to ensure satisfactory performance. Unlike concrete dams constructed on rock foundations, earth dams that remain greater emphasis on stability analysis due to their vulnerability to hydraulic and structural failures. And for the research gap, the previous Ethiopian research has focused on single method approaches, but this study addresses the gap by comparing these two computational models. The first one is GeoStudio and the second one is Plaxis. So the comparative evaluation combines limit equilibrium and finite element methods with real measurement to provide a comprehensive assessment of dam performance and model reliability. So the study area of this Gomit dam is located at Amhara region, south the Gondar zone as the Wareda, with the elevation is 2.375 meters above sea level, and for the catchment area, with the total catchment area is 23.43 kilometers. But the purpose of this dam is for irrigation of 90 hectares that built on Gomit River. So these are the study area of this Gomit dam. So for the methodology, there is 4 steps. The first steps is we have to collect the primary data collection. The primary data is the physical site observation, seepage quantity, measurements using calibrated container, the methods at downstream tool, and stakeholder interviews with construction personnel and current operators. And the second one, we have to collect the secondary data acquisition. The secondary data is the geometrical design parameters, the geotechnical laboratory test result, the geological reports, and the reservoir water levels records from original design documents. And for the third step, we have the computational modeling. So seepage analysis using SIPW and Plaxis models, the slope stability analysis using SLOW and Plaxis approach under 3 loading conditions. And the last method, we have the model validation with compare of computational result with field measurement. So the evaluation of model accuracy and reliability for practical dam safety assessment applications. So these are the material properties. So this table presents various physical and mechanical properties of different soil material uses in geotechnical engineering and civil. So these each material types is characterized by specific parameter which are followed by this material type. So these material properties have 5 material type. The first one is shell, clay core, horizontal filter, foundation soil, and the last one is bedrock. And for the parameter, the first one, there is the gamma saturated, gamma unsaturated, These are the material cohesion, which measures the internal strength, and this shows the angle of internal friction of this material, and these are represents the angle of reluctancy or the internal deformation angle of the material. This is the Young modulus, elastic modulus Young, and these are the Poisson ratio, and the last one, this is the permeability of hydraulic conductivity. So the results, these are the seepage analysis that comes from the GeoStudio running model. So this model findings is analysis conducted at two critical reservoir elevation that reveal significant seepage through the dam body and foundation. So in GeoStudio, this has three running models. The first one at 2,360 meters elevation, the result is 1.496 times 10 to the power of minus with 5 cubic meters per second. This computed flow rate at the full reservoir with the elevation is about 2,367 meters. The result is 2.632 times 10 to the power of minus 5 cubic per second computed flow rate. And the third running model is the actual measured seepage is about 6,712 times 10 meters per second at downstream flow. So the CW model successfully predicted line location that for water pressure distribution and seepage velocity patterns through the 324 meters dam structure. So the seepage analysis by Plaxis model, the first running, the result is about 3,778 times 10. These are at seepage about 2,360 meters that floated in millicubic per second at current water level using Plaxis models. And for the seepage is about 2,367 meters. The result is about 7,497 times 10 with the floated in meters cubic per second at full reservoir levels using Plaxis models. So this Plaxis results higher than CW at comparable water levels. The Plaxis models provided comprehensive visualization of flow fields, extreme velocity patterns, and predicted line positions. So the results of exceed the GeoStudio prediction but remain significantly below measured field values, so suggesting additional seepage pathway through foundation discontinuities. So for the slope stability analysis, with three loading conditions, the first condition is the end of construction, the second one is steady state seepage, and the last one, the loading condition is rapid drawdown. So the first condition, the end of construction, the analysis type is undrained shear strength, with critical concern is upstream and downstream slope stability, with the pore pressures initial condition from construction, and the requires of safety factor is up to 1.3. And the steady state seepage, the second conditions, with the analysis type is strain or effective stress parameters, with the critical concern is downstream slope stability. And with the pore pressure is coupled from CW analysis that requires the safety factor is up to 1.5. And the last one, with the rapid drawdown, with the analysis type is transient pore pressures, with critical concern is upstream slope stability, with drawdown is 12.64 meters depth reduction, with the required safety factors is up to 1.3. So for the factor safety result comparison, All computed factors of safety fall below that require thresholds under all loading conditions, that indicating unstable slope conditions. Plaxis constantly provides more conservative or lower safety factors that compare to slope W or the GeoStudio, with differences ranging from 6% to 22%. And for the model comparison and field validation, for the GeoStudio, it has strengths for the industry standard limit equilibrium approach and faster computation that widely accepted methodology. And for the seepage prediction, the GeoStudio is more conservative and lower estimates. And for the stability results, the GeoStudio has higher safety factors values, so it's less conservative than the Plaxis one. And the GeoStudio is best for routine design with reliable soil parameters. And for the Plaxis models, the strengths of Plaxis is comprehensive fine element method analysis that better visualization and no geometric assumptions. And for the seepage predictions, Plaxis is higher estimated that closer to field measurements. And for the stability results, the Plaxis one is lower safety factors values, so it has more conservative. And the Plaxis one is best for complex geometries and uncertain soil data. So the research limitation and future research opportunities. The first one, for the study limitation, limited geotechnical characterization of foundation discontinuities and factors network. And the second point is uncertainty in material property variability across dam sections. And for the research gap, it has limited comparative studies between LE and finite element method for Ethiopian dam conditions. And the second point is the research gap is insufficient data on performance of remedial measures for similar geological settings. And for the future research, the first point is development of region-specific design guidelines based on comparative model studies. The second one is integration of real-time monitoring system with predictive computational models. So the conclusion of this all, there is 4 points. For the dam safety status, the Gomit dam exhibits unsatisfactory safety and performance with excessive seepage, with the actual is 6.712 times 10 meters cubic per second, an unstable slope under all loading conditions, with the safety factor is lower than the required threshold. And for the immediate actions required, the critical monitoring and surveillance is needed. So it investigates foundation grouting and drainage improvement and slope stabilization measures. So it has to consider the temporary water level restrictions. And for the model selection guidance for dams with high soil parameter uncertainty, Plaxis finite element method provides more conservative safety factors. For routing design with reliable data, GeoStudio limit equilibrium is more efficient and acceptable. And for the contributing factors, high seepage attributed to shale limestone foundation with fractures and discontinuities. So its lack of grouting works and potential abandonment leakage and inadequate drainage provisions. So that's all for my presentation. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.